Yeah, let's look at 11.5 probability with the fundamental counting principle, permutations and combinations. Here are the objectives. Let's go ahead and look at fractions. Whenever you add fractions, you add the top and keep your common denominator. So this would just be 1 plus 7 is 8 over 12. And then we reduce it to 2/3. When you don't have a common denominator, you have to create a common denominator by looking at your denominators. So 12 and 9. You want to find the multiple, the least common multiple is what it is. So I look at all the multiples of 12, and then I look at all the multiples of 9. So it's just counting by that number until I get one that is common, and that's our least common. So 36 will be our common denominator. So in order to change 1/12 to have a common denominator of 36, I need to multiply my denominator by something. Well, 12 times, let's say 1, 2, 3, 36. This can be 3, 36. Oh, sorry, you could not see that. And then the other one is 5/9. I need to multiply the 9 times something to get 36. So that's 1, 2, 3, 4. 4 times 9 is 36. If you list them out in order, starting with your first multiple, which is itself, you can just count your way up. So that's 20 out of 36. And now that we have our common denominators, we can add our numerators. So just add your numerators and keep your common denominator. And then you would look and see if you can reduce, and in this case, we can't. So we'll go ahead and go to the next page. We have 2 examples. Okay, I have an example. It says Angie, Amanda, Michelle, Betsy, and Sylvia have all been invited to a dinner party. They arrive randomly, and each person arrives at a different time. How many ways can they arrive? So this is the factorial because you have part A. We're just use a factorial because 1, 2, 3, 4, 5. Right, 1, 2, 3, 4, 5. So we have 5 spots. And so to find out how many different ways we can order these, we would do 5 factorial. So you can put that in your calculator. Remember, factorial just means multiplying 5 times 4 times 3 times 2 times 1. It's 120. Or you can go 5 and then math over to probability and then factorial. 120. So how many different ways can they arrive? 120 different ways. Okay, B, in how many ways can Angie arrive first and Sylvia last? All right, so we have Angie's first and Sylvia's last. So we have 1, 2, 3 positions that can be mixed up. These 2 are fixed. So we just have 3 positions that we can mix up with the 3 remaining people. So this is 3 factorial. So 3 times 2 times 1. Well, 3 times 2 is 6 times 1 is 6. Okay. Find the probability that Angie will arrive first and Sylvia last. So probability, Angie first and Sylvia fifth. So how many ways can this event occur? It's 6 over total ways is 120. So then we would simplify that. So it's 120. Okay, the last problem. In one lottery, a player wins jackpot by matching all 5 distinct numbers drawn in any order from the white balls 1 through 40, matching the number of gold balls on the gold ball. So we just have one of those, 1 through 30. If one ticket is purchased, what is the probability of winning the jackpot? All right, so we first have the white ball, and there are 40 of them because it's 1 through 40. And we are choosing 5. So it's a combination. Think about permutation, position, combination committee. So this is a combination because order doesn't matter. So we are going to do a combination. So 40, pick or choose 5 for combination. So we can use our calculator to do this, or we can use the formula. So I'm going to go ahead and use my calculator. So there are 658,008 ways that you can choose 5. Okay, then we have the gold ball. And we have 1 through 30, so we have 30 of those, and we are going to pick just one. So that's just 30. So to find out the total combinations, we would multiply these. So this is called total outcomes. So we're going to multiply them. So 19,740,240 ways that you can pick the correct lottery numbers. And we want the probability that you win. There's only one winner. So that is it. So it's just one out of the total number of outcomes.